Okay, so for 2a, we're going to separate the variables to begin with. Now, in this case here, there isn't actually any y variable on the left-hand side, so I don't need to worry about that. All I need to do is move the dx, to the right over here. So I'll get dy equals sine x cos squared x dx. And now I can integrate both sides. Integrating the left-hand side over here is nice and easy because it's like having a 1 dy. So integrating that with respect to y will just be y. The right-hand side is a little bit trickier. We're going to use the spotting a derivative technique here because I notice that I have a cos inside this squared function, and the derivative of cos is minus sine. So basically, the technique I'm using here is this spotting a derivative technique, where if you have a function inside a power, and if you can spot that the derivative is multiplied by that, then what you can do is ignore the derivative completely, raise the power to be add 1 to it, and then divide by the new power. So that's the technique I'm using here, because I've spotted that cos is inside the squared and the derivative of cos is minus sine. So if I put a minus here and a minus at the front there, this is now, the minus sign is now the derivative, like the f dash down here, which allows me to ignore that completely. I've still got that minus at the front from here, and I'll raise the power on the cos, so it'll be cos cubed now, and divide by the new power. And if you wanted to check that to make sure that was correct, you can differentiate that just to check to make sure this is correct. If I differentiated this, I'd have to times by the 3 first. So 3 times minus 1/3 times cos, that would be squared now, taking 1 away from that power. And then we have to multiply by the derivative of the inside function. So the derivative of cos is minus sine. And hopefully you can see here that obviously the minus here and the minus here cancels out. The 3 and the 1/3 cancels out. And we do definitely get back to that original expression. So that's been integrated now. And therefore you can now substitute your boundary condition in here and here to work out the C. Part D, question D. We're going to separate the variables, so the x here and here will move over to the right-hand side, and the y here will move over to the left-hand side. So that's going to give me the sine y will stay where it is, the dy stays where it is, and that cos y that was on the numerator over here, the green cos y, has moved to the denominator on the left-hand side. On the right-hand side, the cos x has stayed where it is, that there, but I've also got an additional cos x on the denominator from this yellow. So that will be a cos squared now. And on the numerator, there is just the dx and the 1. There was nothing left on the numerator because I moved the cos y to the bottom down there. Integrate. Now, to integrate the left-hand side, I know that sine over cos is the same thing as tan. To integrate the right-hand side, 1 over cos squared, I know that's the same thing as sec squared. Now, I know that tan integrates to be ln sec, and I know that sec squared integrates to be tan. And now you can substitute in your boundary conditions to work out your C. Hope that made sense. Let me know if not. I'm happy to explain more or try a different way of explaining it. Just let me know if any of that doesn't make sense.